Right, let's take a look at Eg12. So bodies of mass 3m kilos and m kilos are connected by a light inextensible string which passes over a smooth fixed pulley. With the masses hanging vertically, the system is released from rest. Find the acceleration of the system and the distance moved by the 3m kilogram mass in the first 2 seconds of motion. Okay, so we're going to be moving here from Newton's second law work to the constant acceleration formally. And then after the 3m kilogram mass hits the floor, 10 meters below the point of release, how much farther will the m kilogram body travel before beginning to fall again? So there's different stages to this particular question, so let's take it one step at a time. So this has got a 3m mass, this has got an m mass. So put the forces on it. This will have a weight of 3 mg, this will have a weight of mg. There are going to be equal tensions in the string, and it's going to move in this direction. And that string is long because it's going to drop 10 meters, but leave that to your imagination. Okay, so we got Newton's second law that's going to happen. So for the 3m mass, N2L on 3m, so Newton's second law on the 3m mass would be 3mg minus t equals 3ma. And then on the m mass would be t minus mg equals ma. So we add those to eliminate the t's. Equation 1 plus equation 2, and I'll get 2mg equals 4ma. The masses will cancel, the m's will cancel, and I get a equals 2g over 4, which is g over 2, which is 4.9. So it's going to be accelerating at 4.9 meters per second squared. Find the acceleration of the system, done, and the distance moved by this 3m mass in the first 2 seconds of motion. So we know it's been released from rest, which means u is 0. I know it's accelerating at a rate of 4.9 meters per second squared. I know that I want to find out how far it's gone in 2 seconds, and S is what I'm trying to find. So I'm looking for the Suvat equation that links S, U, A and T. So using S equals UT plus a half AT squared. U is 0, so that goes. So S is going to be a half times 4.9 times 2 squared. Well, 2 squared is 4, half of 4 is 2, 2 lots of 4.9. It will fall for 9.8 meters in those first 2 seconds. So that's my first answer. That's my second answer. Where do we go next? After the 3m kilogram mass hits the floor, 10 meters below the point of release, how much farther will the m body travel before beginning to fall again? So what you need to be clear of in your head here is what happens when that 3m mass hits the floor. When the 3m mass hits the floor, the string will go slack, and the m kilogram mass will continue to move upwards, but the acceleration now will no longer be 4.9 because it will be accelerating freely under the acceleration due to gravity. So at the point of impact, that mass becomes an upward moving projectile, and we want to know how far it travels before beginning to fall again. So at the instant it starts to fall again, it stops. So I'm going to have a final speed, final velocity of 0. The initial velocity is going to be whatever the speed this system is traveling when that hits the floor. So I can have the initial velocity of the projectile will be the final velocity of that. The final velocity of this is 0, and it's accelerating 9.8 meters per second. And we can work out S from there. Okay, so let's just write out what we're saying there. Okay, so the speed that 3m hits ground will equal the initial speed of the m mass when it becomes to move freely under gravity. Okay, so the speed that 3m hits the ground is the initial speed of m when it begins to move freely under gravity. So let's work out what that is. So I know that the 3m was released from rest. So for 3m mass released from rest, it's accelerating at 4.9 meters per second squared. It's falling 10 meters, so S is 10, and I want to find what speed it's traveling when it hits into the ground. So the suvat that links U, V, A and S is V squared equals U squared plus 2A S. So V squared is 0, 2 times 4.9 times 10. So that's going to 9.8 times 10 is 98. So V squared is 98. V equals the square root of 98. And we'll just leave it like that for the moment. So now, for m mass, its initial speed is the square root of 98, and that initial speed is moving up the page, because once that hits the ground, that's still traveling, so it's moving up. Its final speed is 0. Its acceleration is 9.8, it's g, but that is pulling it back down to earth. It's fighting against it, and it's going to make it stop. And I want to work out what S is. Now, because that arrow is pointing in a different direction to that, I can change that arrow to point in the same direction by making it a minus 9.8. Okay, so I'm not sure how you were taught to cope with that in AS, but that's the way that I would suggest you do it, is put the arrows to show the motion, and then before you do the maths, the arrows all have to point in the same direction. So we're still doing U, V, A and S, so we're still going to use V squared equals U squared plus 2AS. V is 0, U is the square root of 98 all squared, plus 2 times negative 9.8 times S. So 2 lots of 9.8 is 19.6. It's going to be negative, so I'll take it over the other side. So I get 19.6 S equals 98. So S will be 98 over 19.6, which is 5 meters. So when that hits the ground, that's going to keep moving upwards for 5 meters before it instantaneously comes to rest, and then falls again until the string becomes taut once more. So let's just check we've covered all our bases. Find the acceleration of the system, we did that. The distance moved in the first 2 seconds, we did that. And after it hits the floor, the M body travels for 5 meters before beginning to fall again.